Hello everyone and welcome back. Today we're doing lesson 2 of atomic structure, naming elements and their symbols, part 2. So hopefully you've had a chance to practice the different elements because we will be talking about them again. So before we get started, there's a knowledge check there. Hopefully you have it in front of you as well. I want you to pause the video and give a go to these questions, looking back to any notes you made yesterday to help if you need it. So hopefully from last lesson you remember most of these. We'll go through them now to make sure you do have all the correct answers that you need. So the rows of the periodic table, hopefully you remember, they are called periods. Whereas the columns are called groups. The elements in the periodic table are arranged in order of their atomic number. The symbol for helium, here you need to be careful again, because remember it's a capital H and a lowercase e. If you've done it, capital H, capital E, it will be incorrect, or if you've done it lowercase h, lowercase e, it is also incorrect. We need that one capital and then the lowercase. So the symbol for potassium, this is a strange one because it's not P like you'd think, because P is phosphorus. It is K, and again a capital K. Symbol for phosphorus here is that P that we talked about for question 5. The number of elements in period 2. Period 1, you hopefully remember, has 2 elements, just hydrogen and helium, whereas period 2 has 8 elements in it. So the element in group 2, period 2, hopefully you remember this, and this is beryllium. So you can do the symbol or you can write the name. Beryllium. So there are your answers. Double check, go through them, make sure you have them all properly. All right, so moving on from there. The first bit here is a bit of review from the last video, so hopefully you do remember it. We'll go through it quickly anyway. The periodic table is an arrangement of elements. Remember that an element is any pure type of atom, so an element has only one type of atom. This is compared to a molecule or a compound, which we will talk about later. They're placed in order of their atomic number. And again, we talked a little bit about atomic numbers yesterday, but we will learn more about those in future lessons. We know that each element has a different symbol with the 2 letters. We know the rows are called periods and the columns are called groups. Periods are labeled 1, 2, 3. Remember that period 1 has 2 elements. Period 2 and 3 have 8 elements. So that 2, 8, 8 will come up again. So, and the groups are labeled 1, 2, 3, 4, 5. All the way up to 0. And sometimes we use the Roman numerals, but sometimes we just use the letters 1, 2, 3, 4, 5, 6, 7. So now I would like you to go through and try again to see how many of the elements you can remember from last time. The more often you go and visit this, the easier it will stick in your head. So I would like you to again write down the numbers 1 through 20 for the atomic numbers, making sure that it is important that, for example, carbon is number 6. Yes, I just gave you a hint, and that it can't be number 5 or 7. And you will learn more about why the atomic number is so important later. And also remembering the symbol needs to be 1 uppercase and 1 lowercase, and not 2 uppercases or 2 lower cases. So pause the video, try your first attempt, see if you can do better than you did yesterday. All right, so hopefully you have these as your answer. Number 1 being hydrogen, 2 helium, 3 lithium, 4 beryllium, 5 boron, 6 should be carbon, 7 should be nitrogen, 8 should be oxygen, 9 should be fluorine, 10 should be neon, 11 sodium, 12 magnesium, 13 aluminum, 14 silicon, 15 phosphorus, 16 sulfur, 17 chlorine, 18 argon, 19 potassium, and 20 calcium. So go through, double check that you do have all of those there as you need them. Try to get them all on screen. You can always use your periodic table as well to help. And then I'd like you to give a try to the second and third one as well. If this format is not working for you, if you're really struggling with it, there are lots of online periodic table quizzes. So just Google any one for the first 20 elements, and you should be able to quiz yourself that way and memorize them that way as well. So once you have gotten all those in, give a go to number 2 and 3. And once you've done it at least 3 times, come back to the video. So some of you may have noticed that the periodic table is not a perfect square or a perfect rectangle, which does seem counterintuitive at first, because why would you not just make it neat and orderly? However, there are lots of little reasons why that's not the case. And as you learn more about chemistry, a lot of those reasons will come out. One reason is because it allows you to construct an atom from its subparts. So an atom itself is actually made up of slightly smaller things, protons, electrons, neutrons, which we will learn more about in future lessons. But the shape of it lets you see, oh, it's in period 2 and group 3. So you can construct it just from knowing that. Even if you don't know what element that is, you can put the atom together based on its part because of where it is on the periodic table. What we're focusing on today is the 2 main sections that the periodic table is split into. We have the metals and the non-metals. So most of you do know what a metal is. If I were to hold up a coin, you would be able to say, yes, that's made out of metal. Whereas if I were to hold up a regular pen, you would say, no, the case of that isn't made out of metal. So that would be a non-metal. So the way that you're doing that, even if you don't realize you're doing it, is you're looking at the properties of the object. So properties are the thing that makes that object different from something else. So properties, what makes it different from something else? For example, the properties of a human compared to a dog is that a human is able to walk on 2 legs, where a dog needs 4 legs to walk. A dog has hair all over its body, whereas humans only have hair in specific parts on their body and things like that. So properties are what make it different. So when we're talking about elements, the properties of metals, most of them you already know quite well. So you know, for example, that metals are always shiny. As long as they're polished, yes, and not painted, but you can always get a metal to be shiny. They're usually quite hard. They always conduct electricity and conduct heat. So this word conduct, if you don't remember from previous terms, conduct means lets it through. So wires, for example, are made out of metal because the metal wires can let the electricity through, whereas the plastic insulation around it doesn't let the electricity through, so keeps it in the wire. It also conducts heat, which is why in food tech class, for example, you tend to use wooden spoons to stir instead of a metal spoon inside the pot, because the metal spoon will get hot because it'll take that heat from the soup or whatever else you're making and travel up the spoon to the handle where you don't want it. Whereas that wood is non-metal, so it won't let that heat travel through. They also have high boiling points. This means it takes a high temperature to boil. So hopefully you remember that boiling is when it turns from a liquid to a gas. So some of you may say, but miss, metals can't boil. If we get them hot enough, they can boil. Most metals have boiling points in the thousands of degrees. So 2 to 3,000 degrees Celsius in order to boil. All right? Whereas non-metals tend to have very low boiling points. If you think about the gases around you, oxygen, carbon dioxide, nitrogen is in the air as well, it's already boiled at a very low temperature, so it's already a gas. So that's comparing the metals to the non-metals. So we said metals are shiny, non-metals tend to be very dull. So while we don't experience many elements as non-metals, as solids, we can think of a lot of other things, such as wood, paper, and plastic as well, whose properties are more similar to the non-metal elements than the metal elements. As I said earlier, the non-metals tend to have very low boiling points, which is why we only experience them as a gas. Which means that it's harder for us to think about them as objects because we think of objects as solids and not as gases. However, nonmetals all insulate electricity and insulate heat. So as I said before, why we use that wooden spoon, because wood has more properties of a nonmetal than of a metal. So it keeps that heat in and doesn't go through the handle. Also, it doesn't let that electricity through, so that rubber has also properties of a non-metal. So there's a link here to a video, so you should click on that, watch through that, and make some notes as well about the properties of metals and why that they behave the way that they do. And then we'll get into the tasks below. So now that you have more of an idea of the metals and non-metals and why they behave the way that they do, what I'd like you to do is find a periodic table, either in your booklet here when your teacher's provided, or just quickly Google one, and look at all the elements that you can and see which ones you know are metals and which ones you know are non-metals. For example, I'll start you off. The example we talked about in the last video was gold. We know gold is shiny, it's hard. We know it has a high boiling point because it takes a lot to get gold to melt and even boil. So we know that gold must fit into the metal side, right? Whereas something like oxygen is a gas, so it has a very low boiling point. So we know that it is a non-metal. So for the non-metals, I'd like you to look mostly for gases, things that you know are gases, and metals, which ones do you know for sure are metals? If you're not quite sure, just leave it out for now, but just look through and see how many you can find are metals and non-metals. Again, you don't have to do it in the booklet here. If you have a piece of paper and you'd like to do it there instead, just make a table, metals, non-metals, and we'll go from there. So pause the video, have a look at your periodic table, and figure out which ones are metals and which ones are non-metals. So hopefully at this point you have a nice list of ones that you think are metals and ones that you think are non-metals. So I'm going to go through the periodic table here, and we're going to highlight in different colors the metals versus the non-metals. So hopefully most of you would have realized that iron is a metal. Copper as well is a shiny, it's used in wires, is also a metal. Aluminum, also a metal, one that you think about on a regular basis. Silver, gold are ones, platinum. These are some that you might have been able to go, oh yeah, I know that's a metal. Lead is another one. Tin, such as a tin can, is made out of metal. Some of the ones that you might not have known as much, but still might have been able to know, things like nickel and cobalt, because you'll remember iron, cobalt, and nickel are the three metals that are magnetic. We have chromium is another one that you might have known. Magnesium is one that you might have known is a metal. And so some of these other ones are names that you might not have heard about, worked with before. Mercury is another one that you might have known. Zinc, gallium. So you'll see they do tend to be in the same kind of area. Some of you might be surprised if I say calcium is actually a metal. Yes, we have calcium in our bones, but it's mixed with other things. Calcium, when it's just on its own, is silvery in color and is a metal. Same with sodium. Yes, it's part of table salt, but then it's mixed with chlorine. Sodium purely on its own is a silverish metal. It is soft, but it is still a metal. All right, so now let's switch our color and look at nonmetals. So oxygen was the one I talked about already. Nitrogen is another one that you might know of as a nonmetal. For example, there's a lot of nitrogen in the air we breathe. Chlorine is also a gas. Helium, you can know as a gas. Neon, inside those tubes, is a gas. Hydrogen is also a gas. So it's also a nonmetal. Bromine boils at a very low temperature, at about room temperature, so it's sometimes a gas, sometimes a liquid. All right. The one that isn't quite a gas, but is still a nonmetal because it is carbon. Sulfur is also very dull in color. It's not shiny. So you should be able to see a bit of a pattern here. How, if we go like this, this is the staircase that we find on the periodic table. It goes just under boron and then down and across all the way down the periodic table. This is the line that separates, so this is our staircase. This separates our metals from our non-metals. So this might be, so you might have noticed that hydrogen here is sometimes shown above lithium in group 1. However, it fits better in the on the other side, on this side here, because it's a non-metal. And for the rest, the non-metals are on the left side of the periodic table. Sorry, the metals are on the left side of the periodic table. The non-metals are on the right side of the periodic table. So you should be able to know that non-metals are on the right, metals are on the left, and that there's a staircase separating them. You should be able to, just from what you know, put that staircase in approximately. The key is to put it between boron and aluminum and then go from there. All right, so now that we've had a look at that, seen the difference between metals and non-metals, I would like you to go through, give this knowledge and application check a try. So there's 7 questions on this page and another several on this page. Do as many as you are able to do, and then we'll take it up in a minute. So pause the video, give it a go. And to finish off the lesson, the answers to the final knowledge and application check. So the rows in the periodic table are called periods. The columns are called groups. Because it says here approximately, If you've written 100, that's fine. If you've been more specific and written 118, that's all right as well. The symbol for hydrogen is a capital H. The symbol for sodium is a capital N, lowercase a. Sodium is one that often mixes people up because Na fits nowhere into sodium, but it's just one that you do need to remember. There are 8 groups in the periodic table, just as there are 8 elements in period 3. So make sure you have all those answers down. Pause the video if you need to, and we'll go on to the next couple questions. So, question 8. Elements are placed in order of atomic number. Element at group 2, period 2 is beryllium. In group 0, period 1 is helium. 7 metals. I have here written the 7 metals that are in the first 20 elements. However, if you've added anything like gold, silver, platinum, iron, copper, nickel, cobalt, any of those, anything from that side of the periodic table, that will be fine as long as you have 7. All right, the question 12, the group and period of fluorine, we have group 7, period 2. The atomic number of carbon is number 6. Calcium has the atomic number of 20. The 7 nonmetals, again, I wrote down all the ones that are in the first 20. There are a couple more. If you've done those, that's fine, as long as you go back and double check. So you have hydrogen, boron, carbon, helium, nitrogen, oxygen, fluorine, neon, silicon, phosphorus, sulfur, chlorine, and argon. And the number of elements in each of the first 3 periods. The first one has 2, hydrogen and helium, and then 8 is in period 2, and there are 8 in period 3. So if you look here, there is an extension activity. I would like you to give these a try and email the answers to your teachers to get feedback on them. All right, we'll see you here next time for lesson 3. Again, remember, go back over the video if there's anything you're stuck on, or don't forget that you can always email your teacher to ask them as well.